All right, hey everyone, welcome back to another week of blockchain. Okay, we'll give it a quick sec for everyone to settle in. Today we're going to kick it off with talking about some Ethereum and smart contracts, which should be exciting for a lot of you. So we'll have Ava kick it off and we'll dive right into it. One thing about the discussion, so there's a little miscommunication. It was posted a little late because we tweaked a few things. So from this point, you'll have 2 weeks to do it. So it'll be due not next Wednesday, but the Wednesday after at 6 p.m. So check out the check out B Courses for more information there. Yeah, so you have an extra week to do it.
Cool, thank you. All right, hi everyone. We've been thinking, when I was a student in this DeCal 2 years ago, it was very easy to get bored and lost during lecture. So we're going to try to make this lecture pretty engaging. It's pretty short. It's about Ethereum, smart contracts, which I know people are excited about. So if you have thoughts, if you have questions, feel free to shout them out, because we want you to be engaged and we want you to be keeping up with what we're teaching. Because I know it's hard, because I wasn't able to when I took the class myself. Okay, so today we're going to go over smart contracts, then we're going to go over Ethereum, then we're going to go over EVM, which is the Ethereum virtual machine, which you don't need to know what that is yet, and then use cases for smart contracts and Ethereum. Okay, so I'm going to go over smart contracts first. Before I start, the slides do it a little differently, but I know that there are some people in this class who have a lot of experience with blockchain, and we teach the class as if you have zero experience, but more and more when people come into this class, they actually have their own knowledge before coming in. So I wanted to go around and have people just raise their hand and shout out what they think a smart contract is. And you don't have to if, of course, you don't feel comfortable, but I think even just in the name, you can kind of guess what a smart contract is. If you want to raise it. Yes? Sorry? A promise. Good. I like that. Yeah. A back code? Backbone for people to build on. Cool. Yeah, I like that, thank you. Anyone else? Maybe what smart contracts are used for? When have you heard the term smart contract being used? Yeah. For DApps, yeah, for decentralized applications, totally. We'll get into that later too. Anyone else? These are all good answers. All right, well, we'll go into what smart contracts do a little bit later, but thank you for participating if you did. So first, we're going to go over Bitcoin, a little review, because we're going to Ethereum today. So another question to you guys, what makes Bitcoin so special? Why do we spend so many lectures describing the architecture of Bitcoin? What about Bitcoin is so special that we are looking at it today? It was the first. That caught on, I guess I would say. The first? It was the first cryptocurrency that got a lot of. Yeah, the first cryptocurrency that gained a lot of traction. Totally. Yeah.
I think what makes it special is that there's the way it launched. Everyone in the world had an equal opportunity to start mining it in 2000.
Totally. So there was this element of democracy to it, where everyone had an equal opportunity to join the network.
That won't ever happen because everyone now knows about crypto, so there's speculation involved when a new project comes out, all that.
Yeah, that's an interesting point, if it can happen again like that. Anyone else? Yeah.
Did it establish the technology of blockchain as we see?
Exactly. It was the first use of blockchain technology, which is why we study it, totally. And so then going back to that point of technology, what about blockchain technology so special? Why is it special that Bitcoin was the first use case of it? Why?
Wasn't the first kind of concept that successfully used proof of work?
It was the first time it had successfully used proof of work, totally. Why else do we study the technology? Why do we study blockchain technology? Why is it special? Yeah. It's a new type of network. It's a new type of storing data. So basically, like the three key parts that we saw, which all of your inputs were totally valid, was that it's this cryptographic identity aspect. So your identity is pseudonymous on the network. It's a blockchain technology. It was the first use case of blockchain technology. And there's this trustless consensus aspect, which is what we had. The whole last lecture was about proof of work. And so this is pretty basic, but just reviewing what we've done so far and kind of reiterating why we're even studying this to begin with. And then what are some of the transferable benefits that Bitcoin gave us that we can then use on a new network, let's say, or for a new project? Some of the aspects are pseudonymous. So there's cryptographic identities that allow for accountability, which is the first thing on the side of cryptographic identities. There's also the democratic decision-making that's made through a consensus protocol that doesn't require trust. And so notice how we didn't say just proof of work here, because last lecture we went over plenty of different consensus protocols. Proof of work, proof of stake, proof of storage, proof of reputation. There were just so many different types. So this is the sort of transferable benefit. Then we also have an immutable ledger of truth, which is the blockchain itself. We have uncensorable. It cannot be controlled by any one party because it's distributed across multiple nodes. And like I said, distributed, so there's no central point of failure. So those two aspects are kind of intertwined. But this is like a brief rundown of again, what are the like benefits that we get from using Bitcoin. And then now we're going to maneuver into smart contracts. So someone said, when I asked what's a smart contract, someone said a promise. So that relates back to exactly what a traditional contract is, which is a written or spoken agreement that is intended to be enforceable by law. So generally a contract is two people make a promise to each other and it's binding. A smart contract is a code that facilitates, verifies, or enforces the negotiation or execution of a digital contract. So it's a trusted entity that must run this code. So in the same ways that you trust a real-world contract to follow through on whatever promises were made, you trust a smart contract is going to execute exactly how it's written. So a smart contract is essentially code that is going to execute a digital contract, and we're going to get into that a little bit later. Oh shoot. Okay. So that was the intro to smart contracts. Very, very high level intro, so I don't know if there'll be any questions yet, but feel free to ask if you have any. Yeah?
I guess a question, an idea of like, I guess there's a legal language, I guess, right, with contracts. So how does that translate, I guess, into code? Translating, I guess, like lawyer jargon into like something else that's more abstract into code. Like how are you able to, defend yourself in that sort of
Yeah. Well, I think part of it too is that it's like open source, so you can look at it first. So you are preventing yourself from getting involved in a contract that you don't agree with because you can see the code before you get involved with it. And then also we're going to get into the syntax of specifically smart contracts on Ethereum later, so you can actually see how they're written and how they work. It's like much, much more intuitive than the way Bitcoin code worked. If you remember the lecture where we like got into the technicals of Bitcoin code and it was like you have to stack it up and then you have to unstack it, Ethereum code is much more intuitive. But yeah, I think you also kind of have to speak the language. Like if you want to really understand, where you stand in a contract, like with traditional contracts, you get a lawyer. With smart contracts, you learn Solidity and like how to read it. But yeah. Any other questions? Cool. All right, getting into Ethereum. So what is Ethereum? Ethereum is a decentralized platform designed to run smart contracts. That's a super, super pivotal difference between Ethereum and Bitcoin, is that if you remember, the purpose of Bitcoin was to be a currency. Satoshi Nakamoto said, I want Bitcoin to replace traditional currencies because this is a better form of currency. Vitalik, up there in the corner, Janice, who was the previous head of education, she just graduated, met Vitalik actually during SF Blockchain Week, and she really likes it, so we didn't take her off the slide. But when he created Ethereum, he wanted to create a platform to run smart contracts. So the purpose of Ethereum is not to be a currency, which we'll get into later. But basically, it's a distributed computer to execute code. And it's an account-based blockchain. So where Bitcoin had UTXOs, if you remember, so like little piggy banks that were attached to your name, Ethereum uses accounts. So it's more like a traditional bank account where you add and subtract from your balance. And so we'll see how that's easier later on. And transactions are equal to the state transaction function. And then Ethereum has a native asset called Ether, which a lot of you have probably heard of. And it's you kind of want to compare it to Bitcoin, like, oh, Ether, Ethereum, Bitcoin, the Bitcoin network. But an important difference, like I said, is that Ether is used in order to run smart contracts. So the only reason that Ether exists is because it helps the smart contracts run more efficiently and it helps the network run more efficiently. It's not there to replace currency or to be its own currency, if that makes sense. So that's an important difference between Ether and Bitcoin. And yeah, so it's a basis of value in the Ethereum ecosystem. So some of the implementation details of Ethereum, it takes a block about 13 seconds to be created versus around 10 minutes in Bitcoin, so it's faster. The exchange rate, we didn't update the slide, but in 2020, so 1 year ago, it was trading at $367, which is kind of crazy. I think it's 10 times that today. I don't know what the price, does anyone know what the price of Ethereum is? 35, cool. So then 6 months ago, it was $1,788, and today it's $3,500, somewhere around there. So gaining value every semester. So now putting Ethereum and Bitcoin side by side to see the differences and see okay, let's see which one's better, which one's worse. We already went over this, but Bitcoin is the first successful cryptocurrency. It's trustless, it's immutable, it's uncensorable, it's pseudonymous. There's no central point of failure. There's one CPU, one vote, which is the proof of work consensus mechanism. Every unit of computational power that you have translates to one vote in the network. We haven't really gone over this, but does anyone want to shout out some of the aspects of Ethereum that they think would be up here? Yeah. More environment. We'll get to that actually later. It's a good point. Yeah. Turing complete. That's a good one. Does anyone want to define what Turing complete means? Just in case there are people that don't know about it. What? Well, there's some people in the class who probably don't know what Turing complete is. Well, I think it just means that you can run code on it.
Yeah, I think the easy explanation is you can use loops.
Yeah. You can't write code on Bitcoin basically. You're very limited. It's very simple. Whereas with Ethereum, you can write code on it. You can build smart contracts. Good point. Anyone else? No? All right, we'll get to it. So Ethereum, I think we have Turing complete right there, so good point. It's a Turing complete scripting language. It's a smart contract blockchain platform, so that's an important difference between Ethereum and Bitcoin. The asset that is used in the Ethereum network is Ether, and it's used to fund computation and align incentives. So we'll get to what funding computation means later in the lecture, but it's not, the primary purpose is not to be a currency. It's to fund computation, basically just to make sure the network is running. It's very complex. It has a ton of features, Turing complete, and it's account-based. So the way that addresses work is that your address is tied to an account, which has an Ethereum balance. In Bitcoin, your address owns a certain number of UTXOs, and each UTXO has a certain number of Bitcoin in it, and you send and receive UTXOs. So you can imagine how that takes a lot more memory to do, whereas in Ethereum, it's just plus or minus to your account. Bitcoin is simple and robust. It's stack-based, which is, like I said, where you have to stack things up. It's a very primitive scripting language. It's not Turing complete. And the asset that is in the Bitcoin network is Bitcoins, which is the primary purpose of the Bitcoin blockchain. All you can really do on Bitcoin with the network is transact Bitcoins. And then, so like I just went over, looking at Ethereum accounts, we can look at it in terms of UTXOs here and then account-based model here. So if Bob owns a private keys to a set of UTXOs, it's easy to make transactions and prevent double spending because you know that those UTXOs, those Bitcoins have not been used anywhere else because they're tied into this one UTXO. On Ethereum, where you have a balance, like I said, more like a bank account, it's more space efficient to update balances instead of storing UTXOs every single time a transaction is made. It's also easier to look at balance and transfer between accounts when you're programming it. So you can see he owns a private keys to these set of UTXOs, so he's able to access these UTXOs because he has a private keys to them. Whereas here, this is 10 Bitcoin, and then the equivalent would be 10 Ethereum in an Ethereum account, it's just much easier to look at. You just see balance is 10 versus 5 plus 3 plus 2. Okay. There are two types of accounts in Ethereum. One is an externally owned account. So this is owned by some external entity, a person, a corporation, etc. They can send transactions to transfer Ether or trigger contract code. It contains an address and an Ether balance. So this is like the typical, like Bob's account is an externally owned account. Bob's address is an externally owned address. Sorry. And then a contract account is owned by the contract. So its code execution is triggered by transactions or function calls, and it contains an address and associated contract code and persistent storage. And then how do you control smart contracts on Ethereum? They are like autonomous agents living inside of the Ethereum network. So you can think of them, they're just kind of sitting there until they're poked at. So until someone calls on a contract, it's just sitting there, it's not doing anything. Then you can call on that contract, and then it'll start executing code. So it's going to react to the external world when poked by transactions. Those transactions are going to call specific functions that are going to be within the smart contract code. And the smart contracts themselves have direct control over the internal Ether balance within the smart contract and the internal contract state. And so what's the purpose of a smart contract on Ethereum? Like, why do we have smart contracts on Ethereum? Generally, we break it down into 4 different purposes that they serve. So the first one being to store and maintain data. And the data represents something useful to users or other contracts, or otherwise, why would you be storing it on the Ethereum network? Example, a token currency or an organization's membership is a type of data that you can use a smart contract to store. You can also manage contract or relationship between untrusting users. So example, if you want to execute a financial contract using a smart contract, an insurance contract using a smart contract, you can also do. If you want to provide functions to other contracts, so kind of like intertwining different contracts with one another, serving as a software library, or the last use is complex authentication. So the recipe for mining in Ethereum, this looks very similar if you remember the slide that we did on Bitcoin, except number 1, verify incoming transactions and run smart contract code invoked by transactions. So that's the one step that you add to the Ethereum mining recipe that wasn't on the Bitcoin mining recipe, because like we said, Ethereum is Turing complete. You can run smart contracts on it, which you couldn't do on Bitcoin. So that's why we have this highlighted. Everything else is the same. Download the blockchain, verify transactions, create a block, find a nonce, broadcast your block, profit. Everything else is the same except for that step in verify incoming transactions. So if you remember, to run a full-fledged Ethereum, to run a full-fledged Bitcoin node, you had to do all these things. So if you want to be a full-fledged Ethereum miner, you have to run all the smart contract code that's invoked by transactions. Ethereum is a distributed computer, which we'll get into in the next section, which Nate will go over. Its distributed consensus protocol is proof of work. So someone raised the point of Ethereum being more environmentally friendly. It actually isn't right now, because it's still using proof of work, which has the same environmental impact as Bitcoin. But there's the proposed Ethereum 2.0, which is intended to move to proof of stake, which would be more environmentally friendly, which if you remember, we went over in the past lecture, how proof of stake works versus proof of work. So I'm not going to go back over that today. And then the network consensus removes the need for a trusted third party. We remember that from Bitcoin. And there's secure peer-to-peer agreements that live on the blockchain forever. We remember that from the Bitcoin blockchain as well. Okay, pop quiz question. You guys can just talk amongst yourselves for a few minutes. What types of transaction model Ethereum uses? It's an account-based system. It's a UTXO-based system. It's very simple and robust. It's complex and feature-rich, and it's a smart contract blockchain platform. So this is multiple answers, so you can just choose all the ones that you think are true. Discuss for a couple minutes, and then we'll come back. Okay, hope you had some good conversations about the pop quiz. Does anyone want to shout out what they think the answers are, or an answer that they came up with their? Okay, so someone said A, I heard B. D, sorry, D, A, D, E. Nice. Good job, guys. Okay, so those are the answers. It's an account-based system, which we just went over. UTXO, who uses a UTXO model? Yeah, Bitcoin. Who is very simple and robust? Yeah. And Ethereum is complex and feature-rich, and it's a smart contract blockchain platform. So the last part of this section of lecture is going to be just like looking at what a smart contract code looks like. I know someone was asking about it before. This is, I think, betting on Ethereum, which is actually one of the use cases we'll go over. But this is just kind of like to get familiar like with what a smart contract looks like. And if you're not a computer science major, if you don't really like know what this is, then you can just look at it for fun. But yeah. It's a good question. Do you guys, hey, is blockchain betting allowed legally in California? I think like blockchain betting in general is like pretty illegal because you can have, which we'll go over, but you can like.
No, I feel like it is legal because you can do like legal.
No, but you can have like assassination markets.
No, but people like gamble these like video game things and like.
On a blockchain?
It's always like in Ethereum because like it's.
Yeah, but they use Ethereum, but they don't run the. Well, that's a good question. If anyone knows.
You're technically not allowed to do it in California, state to state, but if you use like an IP address that's coming from like New Jersey or something, you're totally chill.
All right, you're technically not allowed to do it in California, but if you use an IP address from New Jersey, you're chill.
Any betting in California is illegal, except if you're on an Indian reservation.
Any betting in California is illegal unless if you're on an Indian reservation. So if I go to an Indian reservation.
I'm not sure. I assume so.
All right, cool. Well, that can be someone's homework for next week to look that up and then come back with the answer. Cool. All right, Nate's going to go over the Ethereum virtual machine.
All right, it is time for some EVM, so let's get right into it. Yeah, you know what, I'll try this too. It looks kind of comfy. Has anyone seen Dead Poets Society? Where like in the last scene they all stand up on the chairs and they say like, "Oh, Captain, my Captain," like the Walt Whitman poem. We'll get to that point. So by the end of the semester, we'll see if we get to that level. Okay, let's kick it off. Let's get into some EVM. So EVM stands for Ethereum Virtual Machine. And I'll just explain a little bit about how it works. So pretty much just like some other compilers, what we see is that we start off with some kind of language that is like more similar to English. And so I guess most of the code that we interact with, or maybe that we may see from time to time, is kind of similar to English. And so what we see here, like the two main forms, or like examples that we see with Ethereum, with EVM, are Solidity and Viper. And so Viper you can think of more as like similar to Python, whereas Solidity is more of a mix of Java and C++. So what we see is we kind of interact with this code using these languages, and it goes through a compiler, either the Solidity or the Viper compiler, and then gets turned into EVM code, which is able to be used directly, like kind of fed directly into EVM. So we can think of like the Ethereum virtual machine as just a mini computer. And it's a computer it's like a mini computer on your own computer, and it runs the contract code, and it helps to execute this code so that things run effectively. So contract code so we can also keep in mind that the contract code gets executed on every node. And so pretty much what this means is we see it being run on all these different computers. Like the mini computers inside of each computer all run this code, and things all work in collaboration to achieve like a bigger goal. And so like to keep in mind, like the last thing is that every Ethereum node runs EVM. So every single device that we see will run EVM here. So this brings up one of the challenges and one of the biggest issues that comes up, which is of infinite loops. So what happens if our contract does have an infinite loop in it? And what an infinite loop is just a loop that doesn't have some kind of ending condition. So the code will continue to run and run and run and take up all this processing power and will never terminate or reach some kind of endpoint or end goal. So what we'll see is if the smart contract or if there's some snippet of code that has an infinite loop, then every node of the network will get stuck executing the loop over and over again and will never come to some kind of termination. So by the halting problem, it is impossible to determine ahead of time whether the contract will ever terminate. And so what we see is this thing called a denial of service attack, where we don't come to any kind of conclusions in this situation. So this is a problem because if you think about how many EVM nodes there are out there, it takes up a lot of processing power and it backlogs all the other transactions that are trying to go through. So that's why it's so problematic that infinite loops, it can really, if you're looking from a hacker or some kind of malicious standpoint, infinite loops are the ways that you would be able to compromise or really slow down EVM. So this is where we introduce gas. So EVM, raise your hand, by show of hands, has anyone heard of gas? Does anyone want to shout out what that means to them or what they've heard about it? It's expensive. What was that?
No, you go to gas, what the fuck, or WTF, like, tell you how much money you spent on gas before.
Okay. So yes, you can check your gas online, you can check your gas prices and anything else. Can anyone explain what gas is or what it does? I mean, it kind of says it on the slide, but I'd love to hear it in someone else's words. Transaction fee. Basically it's a transaction fee. And so it makes sure that everyone who wants to use the EVM, which is a service, anyone that wants to interact with the EVM will pay some initial transaction fee for each transaction, each snippet of code, for every interaction that they have with the EVM. That's where we see gas coming into account. So every EVM operation code requires some gas in order to execute, and there are two components to it. So we have our start gas, which is the maximum quantity of gas that it's willing to consume, and we have our gas price, which is the fee in Ether, which is like the native currency that is willing to pay per unit of gas. So this is just a little bit of the timeline, how it works with each transaction. So at the start of the transaction here, we see that our start gas is multiplied by our gas price. All this is done in the native currency of Ether, and subtracted from the sender's account. So start off by, you front this fee. You pay your gas, and you do that on the front side of the transaction, and then we go through the interaction, and if the contract successfully terminates, meaning there aren't any infinite loops and it finds a way to end, then the remaining gas is refunded back to the sender. So anything that was left over goes directly back to the sender. And if the contract runs out of gas before it finishes, then the execution reverts. So it goes back to the initial state. So that's where we refer back to the earlier state. And the start gas times the gas price, these are not refunded back to the initial address. So that goes to show, well, pretty much if I were an attacker and I were trying to kind of mess with the network in some way or mess with EVM in some way, then I could pay a lot of gas and I could run these infinite loops, but it would be so expensive that no one in their right mind would do it, and no one would really be able to do it. Yeah, question.
So the gas, when it's taken from the sender's account, where does it go?
It either goes, so we'll get into that a little later. Yeah, but pretty much that'll make more sense in a bit. But yeah, I think just right now a good way to think about it is it goes to, it's all fronted and then whatever's left is restored. So kind of similar if you want to think about it like the UTXO, like the leftover is refunded back to you. So with each state, we can think of EVM measuring something called state changes. And so these means, if we think about Bitcoin, we have blocks that are added. In a similar way, we have different states. And these are pretty much parameters, and they outline what changes we want to see made. And so with this whole idea of state changes, there's a lot more that goes into each transaction, which is why it's a lot more complicated than understanding Bitcoin. And so even right here, these are a few of the components that go into each different state change or transaction. So we see the state, the gas involved, memory transaction, if there's a message, the code, stack, and PC. And so some of these will make sense in a little bit, but you don't have to worry too much about these. So, little pop quiz. Turn to a partner or someone, turn to a neighbor. What do start gas and gas price refer to? Or don't turn to a partner, and you can think on your own. Oh, sorry, everyone's reading. Okay, has everyone gotten a chance to talk through this? Yeah? Okay, by show of hands, who thinks it is, and also, okay, yeah, by show of hands, who thinks it is option A? Who thinks it is option B? And who thinks it is option C? Sweet, so option B is the correct answer here, so. We see, so our start gas is the maximum amount of gas that the owner is willing to pay, and then the gas price is the price of gas in a way, which is like the denomination of units of ether per unit. So just to go over what this means for Ethereum. So Ethereum isn't necessarily about optimizing efficiency of computation, but what we're seeing is that because everything that is run on every node, it isn't really optimal, and it's not done to do this. But instead, we're looking we should look at Ethereum in a way to understand how it's a way to reach consensus on the system state, and so how we can create this really robust form of consensus without needing third parties. So like we see with blockchain as a whole, a lot of the times efficiency and optimization isn't really the main factor, but instead we see consistency and honesty and security. So what we see here also, like contract executions are redundantly replicated across nodes. So it really is somewhat pointless to have all these nodes be replicating these EVM computations. And what goes with that is it is expensive, slow, and it really takes up a lot of memory and bandwidth. But it creates an incentive not to use a blockchain like for computation. So it shows that there is an incentive to do things that are done off-chain. And so in a kind of implicit way, it creates people to take a look back and sense and kind of see if it's even worth it using blockchain. So there are a lot of situations where I wouldn't recommend using blockchain, and most people wouldn't either. And so because of these components, it allows people to really assess if they should use a blockchain or not. So like even right here, we'll get into some examples, and maybe for some of you, if you have ideas that you're interested in potentially pursuing that involve blockchain, then this might be helpful for you too as well. So I would say like a lot of the times you want to use blockchain if you need a shared database, and you need some kind of shared idea of truth that you can update and use effectively. So, and at the same time, blockchain is really crucial if parties can't trust another, and there is no third party that either wants to be involved or should be involved. So if everything is done among parties that don't need some kind of regulatory group other than the underlying blockchain mechanisms. And finally, you would want to use blockchain if you're interested in fault tolerance, data immutability, or even censorship resistance. So any of these things that you want to work through, like any of these partitions, then you'd want to use a blockchain. That being said, centralized databases are really effective in a lot of other scenarios. So if you don't need a shared database, if it's internal, if it's within a company, and you all trust one another, then it's much more efficient to use a shared database. And if you want to keep data confidential because of the generally more public information, or like the more public nature of a blockchain, you'd want to use a centralized database. More than that, if you have a lot of complex and large amounts of data, then you guessed it, centralized database. And finally, if you need to be able to edit data and you're interested in cost effectiveness, speed, or efficiency, because we see that these are the compromises that come with having no third party or security. Welcome, Connor. So, we will get into the state machine. Actually, no, we will. Okay, well, I'll just get into some use cases now. So this is our last section where we can talk about how Ethereum is used nowadays and what we can expect to see in the future.
Woo, last section!
Yeah, today's a shorter lecture because last week was a little bit longer, so this one should be quicker. So, a few use cases. This is probably what you'll hear when people talk about Ethereum. For starters, has anyone heard of ERC tokens? Maybe ERC20, any of those? Okay, so pretty much Ethereum tokens are, well, for starters, what we see is that we can use Ethereum tokens as different ways of governance. And so what this means is in terms of so dApps, decentralized dApps, DApps, whatever you want to call them, these are all apps that are built on Ethereum using smart contract code, and these components here typically need some kind of currency or token that they can use as like the underlying governing resource. Because as we see with economic incentives within a blockchain, we need some kind of resource that we can use to provide incentives and economic incentives of profit. So as long as we have a token that can be used for profit and that can be used and is actually valued and desired, then we can use this to make sure that everything runs smoothly in a dApp or a decentralized application. So this slide just talks about the whole idea, like one idea, which is that essentially if you really distill down the core of Bitcoin to 4 lines of code, it can replicate, it gives you a very basic understanding of how Bitcoin can work. And these are, if you abstract away a lot of like kind of the beauty, that's things you missed out on, a lot of like the beauty and optimization that comes within like what Bitcoin, like the Bitcoin core developers have built. But this essentially serves like a very bare bones structure of Bitcoin. And it's just the idea of transferring like currencies and tokens to different addresses. So one basic use case through Ethereum is the idea of a public registry. And so we can use this in the idea of like a domain, DNS, which is like talks about domain names. And so creating addresses and creating communication that is not only available but also consistent. And so it means that all these domain names or systems that are outlined within Ethereum are all updated and they're all in sync with all the other nodes that are operating on EVM all operating with EVM. So what that means is you know that you have a pretty foolproof way to be able to store and interact with these domain names or this like DNS system because Ethereum is so widely available and all the nodes are on the same page. Okay, so just getting into, there's also an idea of like a public registry. So this just gets into how you can prove ownership of a document or whatever it may be, like some kind of resource that you want to keep private, but you want to prove that you own it. And so I'm curious, this is kind of similar to the idea of NFTs, but the difference with proof of existence is you don't actually have to reveal the contents of that document or whatever it is you want to prove ownership of. So that can all be private. And you can do this through timestamps. And something that actually back in, if you want to transition into the legal system, a way of like proof of idea, or like intellectual property, something that's often done is people will write down their ideas and then mail envelope of their idea to themselves with a timestamp through the USPS, like the US Postal Service. And this can be a document that's used in court to verify, one, that the timestamp is before like whatever the time period you're wanting to argue is, and two, that you did have this idea first and you were able to kind of have like a very loose form of patent. And so this proof of existence through Ethereum is just a way that you can do this, but you do this all virtually. Okay, and something else kind of pretty similar to this is verifying documents that demonstrate ownership. So it's pretty similar, but one is talking about land titles and having ownership of a house. And so if you're able to upload these documents or find a way to track your ownership of certain pieces of land through EVM, there's the potential that maybe the government or whoever's regulating land will not have secure or even accurate documents accurate representation of that would document you as the owner of a piece of land. And so being able to do this through Ethereum is an effective way to not have to go through the government or whatever the third party is. So most of what we see here is these use cases in Ethereum are all ways to avoid a third party and be able to do things yourself. I mean, that's how I think of Ethereum and blockchain as a whole. So that's just a little more there. We'll skip that though. But this just gets a little more into how you can do this, and you can do this. But you can check that out later. There's not too much for me to say there. And so that's the another thing. That's the thing right there, which is that your information that you receive from an EVM contract or any kind of messaging that you'll get from EVM. The issue is that, and this is something that's often said when talking about smart contracts, like garbage in, garbage out. And on the other side of that, like good data in, good data out. If you're feeding reliable and really trustworthy and pretty accurate information into your system, and the smart contract will run and execute the code, if everything there happens effectively, then you'll get the results that you want, which is honest and accurate results. That being said, if you don't have trustworthy sources or ways to input your data, then it can be really difficult because that's what I see as one of the most compromised components of this decentralized component, because if you have one person who's just inputting information, then the whole system essentially turns centralized. But at the same time, if you're able to find a way to feed in data from a lot of sources that is reliable, and you have strong smart contracts that are robust and will work effectively, then you'll know that you can trust the output that you've created, and you can trust this new state. And so we'll get into DeFi a little later, but this is where the idea of oracles comes in, which is ways to input data that is reliable and effective. Another use case we might see is microgrids and ways to optimize different housing situations, whatever it may be. And so the example we have here is, let's say we have an imbalance of energy across a group of houses, like a consortium. And house A has excess heat, but house C lacks heat. And so we have these two houses that both have, we see house A has what house C needs. And so we can use Ethereum to have them all communicate with one another. And you can use sensors or different external inputs to be able to allocate this heat better. So this is going to be a very brief overview of DeFi, more conceptually than any of the specifics. We're going to have a whole lecture on DeFi, so please save your DeFi questions for that lecture, because it'll all make a lot more sense. But this is just talking a little bit about the philosophy of DeFi and why we're seeing it become so adopted nowadays, or so widespread. So the issue we have is that most of traditional finance is closed to the public. And kind of getting into that, so derivatives or assets, anything that we might be interested in, like stocks, bonds, actual cash, when we see that a lot of them are typically traded through banks or through different legacy systems that already exist and are pretty centralized. And so the challenges that come with this are that financial institutions can manipulate these markets, they can keep them as private as they want, and you might not always even trust banks. So that's where we see some of the criticisms that come from the current banking system. So the Ethereum solution which is that you can build out dApps using smart contracts and use like game theory and economics, like we talked about in past lectures, to be able to trust that the blockchain, like Ethereum blockchain, will verify these transactions, and so you don't need a bank to do so. And so some of the challenges that we see are that, one, it's pretty inefficient because banks that are centralized are able to, they've been around for a while, they've figured out how to do things effectively, but we don't see the same thing in terms of, because we still need to come to a consensus, and there are a lot more factors that come into DeFi that all run through like blockchain consensus mechanisms. And then we also have risks from, like we have smart contract risks or ways that maybe funds might get drained or taken, compromised. There are a lot more factors because it is such a new field that we haven't really experienced all of. And that's why I expect that we'll see many more attacks as the years go on, because there are things that people really haven't thought of, and there are ways that these systems can be exploited. And so that being said, there is like the front-running behavior so there is kind of a hierarchy towards which transactions will be picked up first, like we saw earlier with the idea of like within the mempool. And so this is one of another drawback that we see. So getting into let's get into two more use cases right here. This one is the idea of prediction markets. And so this is kind of similar to the idea of gambling, but we see that prediction markets take wisdom from the crowd, take general ideas from people who are all they all have an opinion, and they find a way to input this information, and it will report outcome. And so what we see here, and this is where the idea where bias can definitely influence data, but if we have, we'll start right here with this example. So let's say we have a question, who will win the 2020 presidential election? And so bets are replaced with shares of outcomes. So people will actually kind of place bets, and they'll provide their opinions. And the oracles, which are like ways that data is inserted into smart contracts and then executed, oracles will report this, will take in this information and all this data, and then apply it and kind of introduce it into the system, into Ethereum. So there are these ideas of prediction markets, which are able to kind of crowdsource and take information from a large group of people to try to make informed decisions. So a lot of times, if you think about it, most of the wisdom that we as human beings have is from groups. And we can think of the idea that the sum, kind of all of us together, I'd say in any scenario, all of us working together on one thing will be so much more effective than single one of us, because we'll have all of our information and all of our own knowledge that we can pull together and put towards whatever we're trying to solve. And that's the same idea with prediction markets. You're comparing a whole group of people who are explaining their thoughts or kind of giving their input versus maybe one or two people trying to make an informed decision. So that's the difference we see. Okay, so some examples of prediction markets. We see buying information. So if we think about stocks, if we think about even all of us together, if we want to talk about if a currency is going to rise or fall. We see with insurance, and also one that's a little more niche, but the idea of security bug bounty and figuring out if there are issues with the smart contract. And so I'm sure you can think of tons of examples of how prediction markets might be effective, and examples when they could benefit you as well, or benefit all of us. And the last one I want to bring up is the idea of a prediction market this is kind of an edgier example, but this has come up, and this idea of the assassination market. And so you're making a prediction or a bet, whatever it may be, that a certain person will be alive on October 4th. And so if you have enough people who are betting on this, and the stakes are high enough, then this kind of shows that incentives can really influence these prediction markets. Because if you're incentivized, and if you know that you can make $1 million if someone isn't alive in a week, then that's kind of a lot of incentive to kill them. And I know it's kind of a grim way to end, but it shows that these prediction markets can really influence, the incentives from these prediction markets are so strong a lot of the times that they can lead people to do a lot of things. And so I guess when you leave here today and walk around, think about how you're incentivized to do things in life, not in the context of assassination or anything, but just think about how incentives drive you and drive all of us in communities. What incentivizes us to do well in school or to even go to class. If you just think about incentives, then you'll see a lot of why different prediction markets are so effective. So that's it for me. Any questions? It didn't reload here. Any questions?
We're still going to go over gas of where it goes.
Yeah, that'll come up a little more in DeFi, but I can talk to you about that. Pretty much, just in terms of gas, a lot of times it's all kind of outlined by smart contract code. So pretty much it gets locked up, or it either goes to the miners. And during this time, then it kind of just stays there, and it's slowly like siphoned away, like parts of it. Whenever it's used up, parts of it get used, and then anything that is left will go back to the miner. So it's pretty much given and to the miners to let them execute the code, and then it'll all go back. So there are a lot of moving parts, and it will make sense in a few more lectures. So I might ask you to table that for now.
The benefit of like having these prediction markets run on the Ethereum network, I guess in the sense of like the eyes of the Ethereum network, is having these types of transactions beneficial to the network? I guess it's just usage of the network, right? You get a gas transaction from executing these contracts. So, I mean, I guess it's beneficial to run these types of.
Yeah, I guess you can. Well, if you just think of it as like a pay-per-use, like if you think of it